Now I'm gonna stack it on the rest of your balls, alright? And I'll just drop it from the
Pay
same
attention.
point.
Be alert. Oh, that didn't work. So we're gonna try again. Oh, there we go.
Oh, wow.
Oh, that was cool.
Let's do it one more time. Did everyone pay attention? Did everyone see that?
Wow.
Okay. So now we're gonna talk about. We're gonna do a little compare contrast. What did we observe? What did we see? Yes.
That when you stacked all of the balls together and you bounced it on the table, the red ball came off and bounced on its own.
Exactly. Okay. So let's take the comparison of the red ball on its own to what happened after it came off the other ball stack.
So like what type of energy?
Or like, what did you observe with like the height difference or anything like that?
The height difference on its own was smaller than what it was with the rest stuff.
Exactly. Did everyone hear what he just said? So when it was by itself, it did not bounce as high as when it was attached to all of the other balls, correct?
Interesting.
So why do we think that happened? Ava? It had it's the same little red ball, right? So it's the same amount of mass.
I think you meant more mass because of the other materials.
Oh, because we added on the other materials. Okay, yes, that is a component of it. And in the blue tie-dye?
Leland.
I think that the red ball is just bouncing by itself, and once it was stacked by the other ones, it bounced off the rubber balls, so it bounced a lot higher.
Right, so there is a component of energy transfer between the balls, right? And this is kind of where Ava's idea of the mass kind of plays a role. So the other balls are heavier, they're larger, and they're all being dropped from the same height. So a ball that has more mass has what, in comparison to a ball that has less mass, has how much potential energy? More potential energy, right? So if you add up all the different energies that go in, the potential energies that are from the additional balls on the Astro Blaster, that energy then gets transferred to that smaller ball on the top, right? And gives it the ability to bounce higher because the energy has been transformed into kinetic energy. Excellent. Question.
Just get more of an idea in my head. Would it be like when you double jump someone on a trampoline, like when there's multiple people and one person just goes flying up there?
Yes, very similar. But if you incorporate that on the trampoline, we're incorporating elastic potential energy. Exactly.
So the point there is that the distance and the mass are the two things that create the gravitational potential energy turns into kinetic from, right? And that was the difference with the ball by itself versus with all the others on the Astro Blaster.
Yep. Okay. Any questions on that?
So you can just jot a note, Astro Blaster. So height, position, and mass are the components of what make up the gravitational potential energy. The position and the mass.